In the last video, we spent a lot of time comparing rates that had fractions in the numerator and the denominator, or both. In this activity, we're going to be working more with decimals, and the goal is to convert between customary and metric measurements. This table is a reference for you. This tells you equivalent amounts in the metric and the customary system for length, mass, and capacity or volume. And our first task is going to be comparing distances in kilometers and miles. Problem number 1 here says that to train for a marathon, which is 26.2 miles or approximately 42.2 kilometers, underline that, that's important. Runners build up their endurance by running shorter distances. Complete the table by writing the unknown measurements. Round to the nearest tenth. Now, going back to our table from before, we can see that the 1 kilometer is equal to basically 0.62 miles. It's an approximation, but 1 kilometer is about 0.62 miles. Let's write that down. 1 kilometer equals 62 hundredths of a mile. So let's look at our first row together, the short distance. Here's one strategy that we could use to find the number of miles in 5 kilometers. We could multiply by the unit rate, like we did in the last lesson. We know there's 62 hundredths of a mile in 1 kilometer, so we could just multiply 5 kilometers times 62 hundredths of a mile over 1. And multiplying that together, what do we get? 3.1 miles. And that's what we go in the first row of our table, 3.1. Notice, just like before, our units will cancel out, leaving us with miles as our units. Now, some people prefer to convert measurements using proportions. Check it out. We could write the proportion that I've just written to find the number of miles as well, and this would work. It would give us the exact same answer. Here we've written a proportion that compares kilometers to miles. And you wrote proportions like this when you were in 6th grade. So 5 kilometers is to X miles, as 1 kilometer is to 0.62 miles. I know that 1 times 5 equals 5. So 0.62 times 5 would be X. And 0.62 times 5 is equal to 3.1. We did that earlier, so we know that's true. So whether you prefer to use a unit rate or a proportion, you will get an answer of 3.1 miles for this problem. So reviewing your options with you, in red, you have the unit rate method. And in teal, down here at the bottom, you have the proportion method. These are 2 good methods for converting between systems of measurement, and you can use whichever one you like. Your task for the rest of this table is to work with a partner to complete it using the strategy of your choice. Pause the video and set a timer for 10 minutes. And after 10 minutes, we'll check your work, and while you're working, your teacher will be checking your understanding and walking around the room. Hit pause and then hit play when you're ready to talk about it. Take a minute to check your work. Which ones did you get right? Which ones need a little bit of work? If you missed one, see if you can go back and fix it. If you got them all right, look for patterns in the table. In this next example, we're once again talking about length. This time, though, we're talking about meters and feet and inches. The situation is that the zoo earned enough money to remodel an aviary. That's a place where birds live. To figure out the amount of supplies needed, the zoo needs to measure the space. The zookeeper only has a meter stick, not a ruler or a yardstick. She measures the aviary, but needs to know the dimensions in inches and feet in order to purchase the materials. Here's her measurements. She knows that the length of the room is 5 meters, the width of the room is 4 meters, and the height of the room is 2.5 meters. That means if we were going to draw a picture, it would look a little bit like this: 2.5 meters high, 5 meters long, and 4 meters wide. It would be something like that. But remember, we don't want those measurements in meters. We need them in inches and feet to the nearest hundredth. Let's figure out the length together, and then you can figure out the width with your partner. So our table from before tells us that 1 meter is equal to 3.28 feet. Now we have 5 meters. So using the unit rate method, we can take 5 and multiply it by 3.28 feet over 1 meter. And that will tell us the number of feet. So we could say that the length of the room is 16.4 feet. But remember, we need to know in inches. Going back to our table, we see that 1 foot is the same as 12 inches. So we can multiply 16.4 feet times 12 inches over 1 foot. Multiplying our numerators, we'll be multiplying 16.4 times 12. And that comes out to 196.8 inches. So we've answered the questions both ways that we were asked. We said that 5 meters is the same as 16.4 feet, which is equal to 196.8 inches. So now we know the length of the room. Now your task with your partner is to find the width of the room in inches. So you are going to answer with your partner part B. Pause the video, set a timer for 5 minutes, and in 5 minutes hit play so that you can check your work. You've hit play, which means you're ready to check your work. The width of the room, or 4 meters, is equal to 157.48 inches, or 13.12 feet. Check your work. If you missed it, see if you can find your mistake. It is your lucky day today, because today you are not going to have to do part C or part D. We're going to skip those 2 problems for today. Now let's talk about what happens when it's cold outside. During cold conditions, pheasants fly 60 yards before taking to the ground for cover. In other parts of the year, they fly about 2 kilometers. What do you think? Is the length of the pheasant's flight longer during cold conditions or other parts of the year? On this problem, you're asking which is longer, 60 yards or 2 kilometers? Let's take a look at the next problem, because in a second, you're going to work both of these with a partner. Number 4 says that Molly and Shauna volunteer at the zoo and are each taking care of an ostrich. Molly says that her ostrich is 1.5 meters tall. Shauna's ostrich is 5 feet tall. Molly says that her ostrich is taller, but Shauna disagrees. Who is correct? So here the question that you're asking is, which is taller, 1.5 meters or 5 feet? This is your task with your partner. You're going to answer number 3, which is longer, and you're going to answer number 4, which is taller. Pause the video and set a timer for 7 minutes. Once you've had time to look at both of these problems, we'll talk about them together. There are lots of right approaches and right ways to get this problem on number 3. Here's one way. I started with 60 yards, and I'm going to convert that to kilometers. The way I'm going to do it is by multiplying 60 times 1 over 1,760. 1 mile over 1,760 yards. Then I'm going to multiply that times 1 kilometer over 0.62 miles. Canceling out my units, this tells me that I will have my final answer not in yards, not in miles, but in kilometers. Multiplying that all together, that comes out to about 0.055 kilometers, so less than 1 kilometer. So which is longer? Well, 2 kilometers is longer than 60 yards, because 60 yards is the same as 0.055 kilometers. Now remember, this is just one way to solve this problem. Maybe you turn the kilometers into yards instead of turning the yards into kilometers. As long as you have a common unit, you can compare these measurements. Now let's talk about those growing baby ostriches. Well, my strategy here was to figure out how many feet are in 1.5 meters. And to do that, I multiplied 1.5 by 3.28. And what I arrived at is that 1.5 meters is the same as 4.92 feet. So which one is bigger? 5 feet is larger. So in this case, Shauna is right. Her ostrich is 5 feet tall, and that is the taller ostrich. So we can see how being able to use complex ratios to compare rates allows us to answer real world problems. Once again, it is your lucky day because you are going to skip this next problem about ostriches. We've been talking a lot about ostriches, and I'm going to let you skip that one. Which brings us to a table, and this is a real world, very relevant table. In this case, we have Tony. He needs a rate table for his tutoring jobs so that he can look up the charge quickly. Now, we can see that Tony charges $37.50 for 1.5 hours of tutoring. We want to complete the rate table and then figure out how much would he charge for 7.5 hours of tutoring. What I want you to do is pause the video and set a timer for 5 minutes. And your task right now, your do now, is just to complete the table. So if you're watching this video now, that means you've hit play, you have completed your table. Let's talk about one useful strategy for completing this table. One thing that you might want to know is Tony's unit rate. How much does he charge in dollars per hour? Well, let's figure that out. To figure out how much he charges for 1 hour, we just need to take 37.5 and divide that by 1.5. We can write 1.5 as a decimal, 1.5. Now, before doing this division, I am going to multiply both my dividend and my divisor by 10. And what that allows me to do is move my decimal over one place in both my divisor and my dividend. So now I'm able to do a simpler division problem that will have the exact same result. Now I can do 375 divided by 15. This is just going to be easier to do. 15 goes into 37 twice. That leaves me with 75. And 15 goes into 75 exactly 5 times with nothing left over. So how much does he charge per hour? He charges $25 per hour. And that makes it very easy to complete the table. 1 hour costs $25. 2 hours costs $50. 3 is $75. 4 is $100. And then my other values are going to be right in the middle. So a half hour would be half of 25. And 3.5 hours would be $87.50. That's just 25 multiplied by 3.5. Now, how much would Tony charge for 7.5 hours of tutoring? There's more than one right way to solve this problem, so I want you to pause the video again. This is a great opportunity to talk with your partner. And I want you to see if you can find more than one way to answer question B. How much would he charge for 7.5 hours of tutoring? Pause the video, talk with your partner, and remember your goal is to solve this problem in more than one way. So one of the most common ways to solve this problem, and it's a great way to do it, is just to multiply 7.5 times 25. This is a great way to solve this problem. I'm going to just rewrite this as 7.5. And multiplying that by 25 will give us one route to our answer. Multiplying those two values together, I arrive at $187.50. Now, guys, there is a shortcut, and I wonder how many of you found this. Remember, we want 7.5 hours. Well, 7.5 is the same as 3.5 plus 4. So you could have just added $87.57 plus 100. That is another route to this answer. And if you did that, let's see, 87.50 plus 100, you get the exact same answer, $187.50. And that's just using our table. So we get the same answer either way. One last question for you here. Tony made $212.50 last weekend. How long did he tutor? Let's pause this video one last time, set a timer for 3 minutes, and work this out with your partner. If you've hit play, you're ready to talk about it. Or maybe you're stuck. If you're stuck, what you need to do here is divide $212.50 by $25. And dividing those two values, what we arrive at is that he tutored for 8.5 hours. That's actually a lot of tutoring for a weekend. There are a lot more problems in here, but we are going to skip some of these. We're going to skip Pepe's Pizza, number 2. And we're going to skip Abby's drink mix, number 3. I do want to look at number 4 together, but before we talk about it, I want you to look at this one on your own. So take a minute, think about it, and see what can you do with this problem with just you thinking about it on your own. Draw a model, write an equation, use an expression, write a proportion or a unit rate. Whatever makes it easiest for you use your style to figure out this problem. Are you ready to talk about it? If you are, keep the video playing. In this problem, we'll want to use complex ratios to figure out the answer. The square shown is composed of smaller equally sized squares, and we see that 4 of them are shaded. We're told that the shaded section has an area of 9/25 square inches. So 4 squares has an area of 9/25 square inches. Well, what's the area of the large square? Remember, we're comparing squares to square inches here in area. So how many squares are there? 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5 means there's a total of 25 squares. So our numerator in the second part of our proportion will be 25. So we're comparing 25, and we want to know what area will that have. Right now, this proportion looks pretty tricky to solve, but let's see if we can make it simpler. I'm going to take this complex ratio and make it a little bit friendlier. Right now, it's the same thing as 4 divided by 9/25. Well, we know that's really the same as 4 multiplied by 25 over 9. And we know that the denominator beneath the 4 is actually a 1. So let's see. 4 times 25 is 100, and 1 times 9 is 9. Much better. What that allows me to do is rewrite my proportion. And instead of writing 4 over 9 over 25, I can just write 100 over 9 because 4 divided by 9/25 is equal to 100 over 9. So now I have 100 over 9 equals 25 over x. And I know that I can use some simple multiplication and division to solve for x here. 100 divided by 4 is equal to 25. Therefore, 9 divided by 4 must be equal to x, or the area in square inches. Well, that's not hard. Let's figure it out. 4 goes into 9 2 times. And then let's bring down a 0. 4 goes into 10 2 times. 2 left over. Let's bring down a 0. 4 goes into 25 times with nothing left over. All right. So that tells us that x is equal to 2.25 square inches. In other words, the area of this entire square is equal to 2.25 square inches. That one was a little bit tricky. And if you're ready for that one, you're definitely ready for today's Talk the Talk. This is a group activity, which means I want you to do it in groups of 3 or 4. And your task for this activity is to determine which of these statements, or whether each of these statements, is true or false. You must provide 1 or more examples and an explanation to justify your answer. So in other words, if you just circle true, false, even if you guess them all right, you will not get any of these right, because that's not all that you are asked to do here. You can't just tell me true or false. You must provide an example and an explanation. If you want credit, you must tell me whether it's true or false, and you must give me at least one example and an explanation. And if you do that, then you have completed your work on this task. Remember, you're working on a group. You have your classmates to help you here. Read the statements, evaluate them as true or false, give me an example and an explanation.